All right, well, I think we're going to go ahead and get started here. And first off, I want to welcome everyone to today's webinar on what's new in Windows Server 2016 Hyper-V, Cloud Resiliency and Feedback. My name's Angie Syrewicze, and I'm joined today with Aidan Finn. How's it going, Aidan?
Hey, how are you doing?
Good, good, good. Hey, thanks for taking the time to join us today.
It's a pleasure. Always fun to talk about this stuff.
Yeah, absolutely, absolutely. So, real quick, I want to give people kind of a general idea of what we're going to be talking about today. Today really is about what's new, what's coming in Windows Server 2016 Hyper-V. And with that said, there have been so many enhancements, so many improvements and new features that unfortunately we're not going to have time to do a deep dive on every one. This webinar is going to be more of a, like I said, what's coming type of webinar. So what we're going to do here is we're going to cover our agenda. We're going to be starting with some introductions of myself, Hayden, and Altaro, the sponsor. And then we're going to get into Windows Server 2016 Hyper-V and the big highlights. What are the big things that have been announced? From there, I'm going to cover some operations and security type of features that have been announced. We're going to hand things back over to Aidan for discussion on availability, storage, and networking. We're going to have a quick word about Altaro software and then the software we provide. And then after that, we're going to do the Q&A. Now, quick word on the Q&A. Because we have a lot of stuff to cover in the time allotted, I'm going to ask you to hold your questions until the end of the webinar. Now, if we don't have time to cover every single question that we get at the end of the webinar, we always do a follow-up blog post out on the Altaro Hyper-V blog covering the questions that did not get answered during the webinar. So if you ask a question and it doesn't get answered, check back on the Altaro blog in a week or two and we will have a blog post with your question and an answer there. And we are recording this webinar today, so if you want to come back at a later time and view it and try and catch something that maybe you missed the first time, the recording will be out there as well. So, again, my name is Angie Syrewicze. I'm a Microsoft Cloud and Data Center Management MVP with the Hyper-V competency. And I'm a technical evangelist for Altaro software. I provide community support on Altaro's behalf. I do technical marketing like these webinars. I do pre-sales. I blog. I do all kinds of different things for them. Prior to my time at Altaro, I spent the last 12 years providing technology solutions, working for an MSP. I spent some time working inside of Fortune 500 in the automotive industry here in the U.S. I've spent a lot of time doing different things in the industry. But with that said, during that whole time, my focus has always been on virtualization, cloud services, the Microsoft Server Stack, and really I've had a big emphasis on Hyper-V. If you like to follow blogs, we have a great Hyper-V blog out at altaro.com/Hyper-V where I blog quite frequently. And if we have any folks that like to use Twitter, I'm quite active on Twitter. Again, coming back to the questions, if you have maybe a follow-up question that you didn't think of during today's webinar, feel free to hit me up on Twitter. I'm always happy to answer a question. So, Aidan, I'll let you introduce yourself.
And by the way, that's a great blog too, so it's well worth people subscribing to that. So I'm Aidan Finn, and like Andy, I am a Cloud and Data Center MVP with the Hyper-V expertise. I think I'm in year 8 at this point. I'm technical sales lead at a company in Ireland called MicroWarehouse. We're a technology distributor or wholesaler. So I spend most of my time working in Microsoft space, the last 2 years mainly in Azure or Azure, depending on where you're from. And part of what we do obviously is dealing with Microsoft and lots of other brands as well. So a couple of other brands that we specialize in is storage spaces hardware from a company called Data On Storage and HyperConverged Infrastructure solutions from called GridStore that we distribute throughout Europe to Microsoft partners. I blog on aidanfinn.com. I'm contributing editor on Microsoft Virtualization for petri.com. Written loads of books in the past, and you can find me being quite noisy on Twitter as Joe_Elway. Don't ask. It's a long question. I think I actually may have answered that on the Altaro blog once before.
You know, I've always wondered that myself, but we'll have to save that for another time, I'm guessing.
Yeah, it's a long story.
Sounds like it. So
it dates back to before the internet had pictures.
Oh wow, it dates back that far, huh?
Yep.
I'll ask you about it sometime. So anyway, real quick word about the sponsor, Altaro Software. We're a fast-growing developer of really easy-to-use and pretty awesome backup software. Our virtual backup is trusted by 30,000 SMBs, and that virtual backup is our flagship product called Altaro VM Backup. If you're interested, you can go out to altaro.com/VM-backup and get a little bit more information on that. So without further ado, let's get to the stuff that you guys are here to talk about today and listen to, and I'll let Aidan take it from here.
Okie dokie. So from my perspective, every release of Windows Server and Hyper-V seem to have a certain theme, and there's one unmistakable theme in Windows Server 2016, and that's cloud. Everything in Windows Server 2016 that I've observed is about cloud, has been inspired by the cloud, or has even been ported from the cloud. A lot of what you're going to see is actually inspired by Azure. Some of it has actually been ported over, so it's originally code that exists in Azure and has been ported to Windows Server 2016. And when we get to the last few slides, you're going to see how much of that I'm talking about. A lot of management stuff has been made easier. This whole service is more scalable. It's easier to service, and we'll talk about that when we start talking about availability. Our services have higher uptime, and a lot of what's happened in 2016 is actually shaped by you, the person who has used Windows Server 2012 or used Windows Server 2012 or 2 and provided feedback on the user voice website, or has played with the preview releases in this unprecedented preview for Windows Server 2016, because we've had the bits for the last year and a half. We've been using them, we've been playing with them, we've been giving Microsoft feedback on what we think they've done and what we think they should do. So things really have improved, as you'll see as we move on here. So let's focus on Hyper-V first. Lots more features. Now, yeah, lots of older features have improved, but we're focusing on some new stuff here. If you've been using Hyper-V on Windows 10 or Windows 8.1 on something like a Surface or a modern laptop or tablet device, then you may have had issues with power support. Microsoft have fixed that, so that should keep a lot of people happy, including a few journalists. So now we have support for connected standby. You've probably heard of RemoteFX, where we could reveal to a certain extent or virtualize graphics adapters and reveal them into VDI virtual machines or session hosts or whatever. And that's great because it reveals the graphics functionality of a graphics card to a virtual machine with a virtual layer performance. But now we have discrete device assignments, or DDA. And this is like SRIOV, in fact, really is SRIOV, where we can start revealing PCI devices into our virtual machine. So the virtual machine is using it at the physical layer. So we can reveal our nice fancy NVIDIA chipsets, or we could reveal storage devices directly into a virtual machine to have great performance and maybe do HPC stuff within Hyper-V virtual machines. Microsoft have changed the configuration file from an XML or text-based file into a binary file. And I'll have to say there's been a lot of negative feedback about that because a lot of people like to hack that file, which is completely unsupported and really not recommended in any way, shape, or form. The reason that they've done this is basically for the larger customers who are booting lots of virtual machines. The binary configuration does give them better performance at scale. We now are able to see and manipulate the VM version of a virtual machine. So every version of Hyper-V has actually had a VM version, which is something we didn't really see. Now it's very visible in Hyper-V Manager, and it's something that you'll be able to see what version of integration components I've got and what version of Hyper-V I'm running, and make sure that you're on the latest version of the virtual machine. Microsoft have struggled with backup, and we're talking on a webcast that's sponsored by a backup software company, so it's important to talk about backup. Microsoft have struggled with backup, and they've been making strides to improve things. I would argue that 2012 or 2, they really did make a significant improvement to how Hyper-V backs up. But what they wanted to do was remove the reliance on third-party filter drivers in running in kernel mode in the management OS to track the changing blocks of virtual hard disks so we could get incremental backups. In 2016, we get something called Resilient Change Tracking, or RCT. And this is a built-in filter driver that will do that change tracking. It stores it in memory, and it also stores it in disk, just in case there is a reboot or a crash or whatever. So this should improve scalability and performance and the usability of backup on Hyper-V in 2016. Now, one of the things that everyone has asked for if they've been playing with Hyper-V is nested virtualization. And what is this? Nested virtualization is when I deploy Hyper-V on a physical host. And then I deploy a virtual machine on that host. And within the guest OS of that virtual machine, I want to deploy Hyper-V. So I can run a virtual machine inside of a virtual machine. Now, this is something we've asked for years and years and years, particularly those of us who are trying to learn Hyper-V with a limited amount of hardware, or trying to do demos from our laptops and show live migration and failover and all that stuff without having to cart around a case full of Intel nukes or whatever. Or you're running a training organization and you have a limited amount of hardware per student, but you still want to be able to teach things like failover clustering and live migration and Hyper-V replica. But Microsoft said, yeah, we'd love to give you nested virtualization, but we don't have a production use for it. Well, that changed with 2016. So now, with Windows 10 and Windows Server 2016, we do have the ability to run Hyper-V inside of Hyper-V. If you want, you can do Hyper-V inside of Hyper-V, inside of Hyper-V, inside of Hyper-V, inside of Hyper-V, and keep on going. And the performance is really, really good. It's surprisingly good, partly thanks to the microkernelized architecture of Hyper-V. Why did Microsoft do it? Well, really, it's great for us, people who do work in that learning, demo, or training environment, but the real reason they've done it is for something called Hyper-V containers, which we'll talk about in the next slide. So containers are a new way of doing application deployment on a server. The traditional way of deploying an application is I deploy a physical machine or a virtual machine, install an operating system, install software, and it takes time. Even if we have a very finely tuned system center management environment where we've got service templates and VM templates and all that good stuff, it still takes time to deploy and install and configure that software. Containers are a whole new way of doing that from a repository that we link into. So nothing's actually really deployed, it's all basically links with unique data stored within the container running on a host. Now that host can be a physical machine or a virtual machine. Now how is this different to what we've done in the past? Well, in the past we've done machine virtualization. Containers are operating system virtualization. So if you look at the picture on the right, we have two different variations of it. Windows containers are very like what you hear about in the open source world. So you might have heard of Docker, which is a management system for Linux containers, and for Windows containers as well in the future. Windows containers, we deploy applications in a container, and they share the binaries or libraries with other containers, and they share the kernel mode of the OS running on the host with the other containers on the same machine. Now we have a certain amount of application isolation within each container, but we do not have security isolation. So Microsoft want to be able to use containers in customer sites, but they also want to be able to use containers in Azure to run what they call hostile code. For example, they have a feature in Azure called automation, where customers are uploading code, and they want to be able to deploy out some way of running that code, but in a secure environment that protects customers from each other, but also Microsoft from the customers. Hyper-V has the ability to create partitions, which we call virtual machines, and it has a secure boundary between those partitions. So we can have something called Hyper-V containers. This is basically it's a partition that's not really a virtual machine, so you won't see it in Hyper-V Manager, but it has a very stripped down kernel of an operating system, and it has enough to be able to run the application that you want to deploy. And that container is completely compatible with what we have in Windows containers as well. And this is a whole new way of running those microservices that you want to get out really, really quickly. In fact, you can deploy yourself a nice WordPress site with the underlying MySQL in literally seconds. It's really interesting stuff that I recommend you have a look at.
Thank you much, Aidan. At this point, we're going to shift the conversation a little bit to more of an operations discussion. It's one thing to have an awesome virtualization solution, right? But it's another thing to have to manage that solution on a day-to-day basis. So really, some of the enhancements that we've gotten in this upcoming release of Server 2016 have really helped us to make our day-to-day life easier as far as managing Hyper-V. We've gotten a couple of new things like hot add, hot remove of memory and virtual NICs, and me personally, that's one of my favorite new things because that was always kind of a pain in the rear end to take care of in 2012 R2. We've seen some slight improvements in Hyper-V Manager. Not maybe as much improvement as some of us would have liked to see, but we've gotten some slight improvements there. Integration services are now being updated and taken care of via Windows updates. That's kind of a big deal because it takes some of the management headache off of the administrator as far as making sure the integration components are always up to date. That can just be done now automatically via Windows updates if you want. And Aidan kind of mentioned this earlier. We've got this concept of VM versions. 2012 R2 VM version was version 5, and the version associates that VM with certain features that are inherent to the specific version. So version 5, that VM could run on any 2012 R2 host, or it can run on a 2016 host as well. But of course, if you upgrade the VM version to the 2016 version, you won't be able to run that VM on top of a 2012 R2 host anymore. So there's some considerations there, but really it comes down to flexibility. If you want the new features, you can have them, or if you want to retain that flexibility of movement for the virtual machine, you can have that too. So again, it comes down to flexibility. Production checkpoints. So I love the first bullet point here. Everyone has a horror story about Hyper-V snapshots or checkpoints or whatever we're calling them these days. It's checkpoints. But I can't even count how many people I've talked to that have essentially shot themselves in the foot, or there was some sort of malfunction, or just some sort of horror story as far as using checkpoints is concerned. They were never recommended in production for a number of different reasons, especially if you were doing a checkpoint for a SQL or an Exchange workload. You could potentially run into some consistency issues. Not to mention they degraded performance, and this one here, especially working for a backup company, was always a little bit of a pet peeve of mine. Checkpoints are not a replacement for backup. You don't get retention out of it. You don't have the management of it like you would with a traditional backup application. They're just not designed to be used in that capacity. But even with all that said, they do have inherent benefits, right? I mean, personally, I've had checkpoints get me out of a tough scrape on a number of different occasions. So, I mean, they're definitely widely used, but we've had to be very careful about how we use them. So what we have now is we've got standard checkpoints. It's basically what we've always had. But now Microsoft has added this new idea, this new concept of a production checkpoint. This is the new default. A production checkpoint is actually going to call backup technology inside of the guest OS, and that backup technology being VSS. It's going to actually use that technology to make a consistent checkpoint of the guest operating system and everything running inside of it. So that's really, really helpful from like I said earlier, like maybe you're running Exchange or SQL or something along those lines. It basically is going to help prevent some people from shooting themselves in the foot. Now, with that said, even though it's the new default, the standard checkpoints are still there, and you can still use them, and whether or not it uses production checkpoint format or it uses the standard, that is a configurable option now in 2016. Another big feature that we have, one of my current favorites, is PowerShell Direct. PowerShell Direct really allows us to push PowerShell code into a virtual machine, into the guest operating system of a virtual machine, without even needing the networking component in play. It does this via the VM bus that's part of Hyper-V's technology, and it's really, really helpful from a deployment perspective. That's one of my favorite use cases for it. I've seen a lot of people tinkering with it and getting trained up on it, use it for things like deploying a virtual machine and then using PowerShell Direct to reach into the guest operating system, install a role or feature, and configure it. It really streamlines that approach and allows you to achieve a level of automation and deployment operations that we didn't really have previously. So again, I kind of mentioned you don't always have network access to the guest OS, and this kind of using PowerShell Direct kind of protects you from deliberate or accidental disconnection. It helps you in those situations where maybe you have firewall VLANs or software networks. It's really helpful in a lot of different situations. So how do you actually use those? How do you actually use PowerShell Direct? So a lot of people are already used to PowerShell remoting, enter PS session or invoke command. Really, we're just doing the same thing. We're just passing the -VM name parameter, issuing the virtual machine's name, and we go from there. It's very, very intuitive, very, very much used to what we're already working with. And this is done from the host via the hypervisor. Like I said, VM networking is not used. And then the requirements. Obviously, it's a new feature, so we need Windows 10, we need Windows Server 2016 on the host and inside the guest OM of the VM. And then we can't just willy-nilly do this whenever we want. We do need the credentials of the guest operating system in order to do this. So for those folks that are more security-minded, rest easy. You at least need the credentials, and if you're really worried about this feature is you can also disable it. So if you want to flat out disable this feature, not let anything run via PowerShell Direct, you have that option. So that kind of segues into more of a security-focused conversation. And security, especially with the idea that most things are starting to move to the public cloud, security is always a big concern. So Microsoft has gone to great lengths to work on the security of their hypervisor, and they've really, really focused on hardening the hypervisor and, by proxy, the public cloud. So kind of two of the lesser features in this conversation are host resource protection. Host resource protection is really helpful in a situation where you have an environment that, depending on how it's configured, maybe you have a high amount of saturation of VMs per host. And it's possible in certain situations for a specific virtual machine to just start consuming a ton of resources and actually be at a point where it's negatively impacting the performance of the host. If host resource protection is enabled, it can actually look at VMs and monitor their resource utilization. And if it detects something that it deems to be excessive usage of resources, you can actually configure it to throttle that particular virtual machine down, to allow the other virtual machines on that host run more efficiently. Another thing that we had added is the ability to use Linux Secure Boot. We've had Windows Secure Boot for some time, and I know a lot of people have been waiting for us to have Secure Boot in the Linux world as well, and that has now been added. So then the more we talk about security in 2016, you've probably heard a lot of talk around the idea of shielded VMs and guarded fabric. The two really go hand in hand. And when we talk about the public cloud especially, there's always kind of a big trust issue. Okay, my virtual machine is running in some data center, or it's running inside of a public cloud provider, public cloud provider like Azure. How do I know that that location is safe? How do I know that the administrators are trustworthy? Microsoft really looked at that question very hard when they came up with guarded fabric and shielded VMs, which we'll get to in a second. So the whole idea of guarded fabric is that in a virtualized world, we know that VMs are mobile, right? They're just a collection of files. And with that in mind, it also means that we have to protect the VMs at the storage and the networking layer as well, and even at the backup layer. What guarded fabric really helps us accomplish is making sure that if that virtual machine were ever taken off site, unbeknownst known to the administrator, that it would not be able to boot. You wouldn't be able to access the information in the virtual hard disk, from the offsite location. And it does this by utilizing a virtual TPM, and it encrypts the data in the virtual hard disk via BitLocker. And this is the real kicker. When you enable guarded fabric and shielded VMs, that virtual machine is only allowed to boot on approved hosts. So that is done by this new attestation service that has been created in Server 2016 called the Host Guardian service. And what this Host Guardian service does is it works with that virtualized TPM, and it verifies, at the boot level that, okay, this host is actually allowed to start this virtual machine. It's just an act of security to make sure that that virtual machine is only running where it's allowed to run. So it runs inside of a dedicated physical domain. You have to have an AD forest specifically for this attestation service, and it runs in two different modes. We've got an admin trusted mode, which is, it's kind of your entry-level guarded fabric implementation. It's good for POCs. It's fairly easy to deploy, and that host trust relationship is determined by Active Directory security group membership. It's not as secure as the TPM trusted mode, but again, easy to deploy. Maybe you don't have as many concerns about a specific location as another, and it's good for those type of situations. The other mode is TPM trusted. It's more secure. I mean, it requires the host guardian service in that mode requires HSM. The hosts in that environment have to have TPM 2.0, UEFI 2.3.1 with secure boot, the whole 9 yards. Basically, in that mode, additional code checks are done at boot time to further verify that, yes, this VM should be running on this host. And then that takes us to shielded VMs. Shielded VMs provide a number of different benefits. Again, we get BitLocker to encrypt the disks. That way, if they're taken off-site, they can't be broken into and mounted up and the data looked at. No console access is allowed in shielded VMs. So if you have a situation where, okay, I don't particularly trust the administrators at this location, with shielded VMs, you can make it so no console access is allowed. You can make it so PowerShell Direct is not allowed. Guest file copy integration components aren't allowed. All these different ways that administrators could potentially reach into the guest operating system of that virtual machine. It also hardens the worker process, the VM worker process of that particular VM, and makes it more difficult for a malicious administrator to, look at that worker process and maybe tamper with it. And then additionally, a shielded VM has its live migration traffic encrypted, the runtime state files encrypted, the save state, checkpoints, basically anything that is very sensitive about that VM is encrypted right out of the gate. So again, if you are housing your virtual machine in a location where you are not quite sure about the administrators, or maybe you're in a high security environment like defense or medical, this is definitely a feature that you should be taking a look at. And I'll pass it back over to Aidan to talk about availability.
So it hurts us IT pros to realize that the business really does not care about our servers, our switches, our SANs, or anything like that. They care about CRM system being online. They care about the web services that are taking credit card information from customers being online. So availability is a big issue. And Microsoft have continued to invest a lot of time, a lot of engineering into improving availability. There's a couple of aspects to that. The first is disaster recovery availability. Now, there's a few ways of doing disaster recovery with Hyper-V, and we'll touch on a couple of those today. But the first way and the classic way of doing it with Hyper-V is to create a very complicated infrastructure called a multi-site or a stretch cluster, where we have Hyper-V hosts running in two different sites but still in the same cluster. Now, one of the challenges with that is we need some way of determining quorum, and the only way to do that when you've got a split brain scenario is to have a third site where each site A and site B each have independent connections to that third site. Now, for a lot of organizations, it's not possible. And that might be for cost, it might be for configuration reasons, it might be for political reasons, it might be for organizational reasons, or they may not even have a third site. So what Microsoft have done is they've said, okay, we'll give you a third site called Azure. You deploy yourself a storage account, and you'll enable a cloud witness in your failover cluster, and you'll have a tiny, teeny little blob storage account. That's basically your file share witness for your cluster. And all it is an incremental counter. And that thing will probably round up to costing about 1 cent per month. So it's not something where Microsoft are looking for your money. It's something where they're looking to give you a very nice, simple solution. Going on with that concept of multi-site clusters, one of the issues we've had in the past is it's basically a flat infrastructure. We haven't had a concept of sites or site awareness in the past, where our virtual machines were owned by a site and should reside in that site. In 2016, we'll be able to map our geographies in the cluster, so we can say that these virtual machines should stay on this site unless something bad happens. When something bad happens, the virtual machines can fail over to the other site, but if it's just a minor issue, they can fail over within the site or live migrate within the site. If you have storage ownership move from one site to the other, then the virtual machines will live migrate to follow that storage as well. That's a very nice feature that solves an old problem in stretch clusters. We get a proper virtual machine start order system, so prioritization of virtual machines has been around since 2012. And we kind of misused it for start ordering, but it really wasn't a good mechanism for that because it was intended for other things. It really was about resource prioritization when we started having a failover and we didn't have enough resources. Now we can start grouping our virtual machines and saying we want this group of virtual machines to start up first, so maybe our domain controllers, then our SQL servers, then our application servers, and so on and so forth. Diagnostics is a big thing in clusters because the reality is every now and then we do have to start troubleshooting. And Microsoft are making that easier, so we're getting the logs more easily, and they're more legible, so we can read what's going on inside of those logs. We're also getting simpler crash dumps that are smaller, so we've got these machines that have 512 gig of RAM becoming more and more common because memory is getting cheaper and cheaper. You do a full crash dump of that thing, that's a big crash dump to upload to Microsoft. Now we can have smaller crash dumps that we can upload to Microsoft. We've also seen the first step of something interesting. We now have support to run failover clustering without the presence of a domain. So we can have HyperV hosts running in a workgroup, or SQL cluster servers running in a workgroup, or stretched across multiple different domains. In the past, all our nodes had to be in the same domain. Now HyperV aren't recommending this, and there's a reason. We need the domain to be able to do live migration. So if we deploy a HyperV cluster in workgroup or multi-domain scenario, we lose live migration. However, there are going to be a niche set of customers who are going to still want to do this with Hyper-V. Maybe they want failover of Hyper-V within a DMZ and they don't want to deploy an Active Directory in that DMZ. Then that's a scenario that's going to be useful for them. Okay. Now, it's shocked me, and I think it shocked a lot of Microsoft people and a couple of years ago when we were at TechEd 2014 in Europe. And we were talking to people and finding out that a lot of big customers were still running Hyper-V 2008 or 2 when they had the ability to run 2012 or even 2012 or 2. And it really did stun us. And the reason was that those customers found it too difficult, too expensive, or too risky to do a cluster migration from 2008 or 2 to 2012 because we haven't had the ability to do an in-place upgrade of a cluster. We had to do a swing migration, build a new cluster beside the old cluster, and then somehow or another get our virtual machines over from one to the other. Now, that very often led to downtime, though between 2012 and 2022 we could do something called cross-version live migration, but that still wasn't enough because we still had to build a whole new cluster with a whole new set of storage. And it was still going to be an expensive, not just on infrastructure, but on time operation. And Microsoft heard the feedback, and we get cluster rolling upgrade. And this is a very interesting feature. It's been heavily tested, and people are reporting back since Technical Preview 1 of 2016 that this is working. And this is something that we're going to hopefully be using to get off of our 2012 or 2 clusters to 2016. Unfortunately, it only supports 2012 or 2, so there's no support for 2012 or 2008 or 2. What we do is we take our first node in the cluster and we drain it of VMs, and we evict it from the cluster, and then we rebuild that host with 2016. So it's not an upgrade of the host, it's a rebuild of the host. We join that old host back to the cluster again. So now we have a 2016 node running in a 2012 or 2 cluster. So the cluster is running in mixed mode. And we're able to live migrate our virtual machines back to that 2016 node. And we'll repeat those steps for the rest of the nodes in the cluster. We still have our failover and live migration and all that good stuff, but we're running at a 2012 or 2 functional level. So this is kind of like doing an Active Directory upgrade. In fact, it's very, very similar. Once all the nodes are upgraded or rebuilt with 2016, we then upgrade the functional level of the cluster. So now the cluster is running at 2016, and then we can upgrade the VM functional levels, which Andy talked about earlier. And we now have ourselves a lovely, brand new, fresh built 2016 HyperV cluster. Oh, and I should say without downtime. Microsoft get a good view of what's happening out in the world through their support services, and what they've seen is a lot of people are suffering downtime because of what's referred to as transient errors. So a switch reboots, a NIC flaps for some reason, a SAN has a glitch, and a few seconds later everything's fine. Now, the problem with these transient errors is the issue lasts for a few seconds, but the results or the negative outcomes of those glitches go on for several minutes or maybe even longer. So for example, if you have a network outage, a very brief network outage, maybe someone pulls the wrong cable, one Hyper-V host in a cluster may stop heartbeating. Now the virtual machines are still running fine on there, but the rest of the cluster is going to go, oh, that machine's isolated, that host is isolated, we need to get those virtual machines off of it as quickly as possible. So they'll do a failover. So the virtual machines stop and they reboot on the other hosts in the cluster, and that leads to some level of downtime. In the meantime, while they're booting up, the host boots back or gets its network back up and running and goes, hey, I'm back in the cluster, but it's not got any virtual machines anymore. So Microsoft are dealing with that. So we now have the ability to isolate and quarantine a host. So isolation is when a host has gone offline for a brief amount of time, and the cluster will be more tolerant of that. If the virtual machines are still operational and they still have network connectivity, those virtual machines will continue to run on that host. However, if that host starts flapping, so by default I think it's 3 times in a single hour, the host will be quarantined and the virtual machines will be live migrated off of it. So that gets the virtual machines onto a more stable host and gives operators some time to start looking at logs and looking at reports about what's going on with their hardware. Maybe they put it into isolation completely or maintenance mode so they can start troubleshooting the operating system and the hardware itself. If a SAN has an issue, say for example a virtual machine tries to write or read to the storage, and there's some delay that can't be explained, traditional response is the machine panics and blue screens. Now that's bad, especially if it's a brief storage glitch, which can happen. So what will happen in 2016 is the virtual machine is going to pause. It will go into a pause state, and you'll see that in Hyper-V Manager. And when the storage comes back, the virtual machine will resume exactly where it was. All the IOPS will have frozen, and they will be released when the storage is back again. So this means we have no downtime of the service effectively. Well, we do have some downtime, but we won't have a crash, we won't have a reboot. As soon as the underlying network or storage comes back, the service will resume. And that is a very positive improvement in 2016. Now I was talking about storage, so let's talk about improvements in storage. We saw a lot happen in 2012 and 2012 or 2. We got this new ability to deploy something called storage spaces instead of RAID. So we started using commodity hardware in these cheap JBOD enclosures. We were using commodity disks where we weren't locked into a single vendor's disk at inflated prices at 80% margins. So Microsoft have built on a lot of what they've done there, plus they've learned from what's happened in the market. So we've all seen the news. Big enterprises in the US have suffered from various different disasters like Hurricane Sandy. But Microsoft observed that these customers didn't have some sort of storage replication system, even though they had high-end storage systems. The reason was the licensing for replicating those storage systems to another site was too expensive. So they just didn't do it. So in 2016, we are getting a feature called Storage Replica, or SOR. And this is the ability to enable volume-level replication from one node to another, or one server to another. It is completely supported by failover clustering and Hyper-V. So if you want, you can have nodes in Site A replicating their storage, their CSVs, to nodes in Site B. And that can be done using synchronous or asynchronous replication. That's going to be a really positive improvement, a feature addition that customers are going to be jumping on very quickly. We've had a very basic version of storage quality of service where we were able to enforce max IOPS on individual virtual hard disks. But in 2016, we're getting something that gives us a lot more control and the ability to start creating policies. On a scale-out file server, we can create distributed storage quality of service rules that are enforced across virtual machines no matter where they are running. And we get the same with block-level storage and cluster shared volumes in a traditional server SAN deployment. So now we can create rules to guarantee minimum IOPS and maximum IOPS on virtual machines, on virtual hard disks, or on individual tenants within a cloud, or within service tiers within a cloud. So it gives us a lot of interesting controls, similar to what you would see in Azure, where you have 300 IOPS or 500 IOPS, depending on what tier of virtual hard disk that you've deployed. Deduplication is an interesting feature. Now, it does have very, very limited support in the Hyper-V world, which is we can only use deduplication in NTFS for non-pooled VDI virtual machines. That policy continues in 2016, but what we do see with deduplication is Microsoft have improved the scalability of it. So the amount of files and the size of those files and the size of the volumes that those files are being stored in. So that's very useful for things like backup and archive, but also in that limited scenario with Hyper-V non-pooled VDI virtual machines. SMB3 is Microsoft's strategic storage communication protocol. It's used by live migration if you've got 10 gig or faster networking. It's used in the storage scenario with scale-out file server. It's also used with storage replica. SMB3 is getting a number of improvements that should improve performance with encryption enabled, and it also improves the scalability of it as well. And my tip of the week here is learn RDMA, Remote Direct Memory Access. That is important. Learn that, learn about things like PFC and DCB. Those are important things for you to learn in the future. So I talked about storage spaces very briefly. What storage spaces gave us was the ability to have Hyper-V hosts that connected to something called a scale-out file server using SMB3 networking on the network. The scale-out file server was built up of 2 or more servers that were SAS attached to a bunch of shared JBODs. I personally find that to be a great architecture. It allows me to put a lot of storage into a very small amount of space, and in small medium enterprises it allows me to deploy a solution in a 2U enclosure, which is great. But Microsoft wanted to look at other ways of doing storage. They wanted to embrace the whole commodity approach and simplify and flatten the architecture. So with Storage Spaces Direct, or S2D, we're removing that SAS layer. There is no JBOD. Well, you can still use a JBOD, but you don't have to. Instead, you can use the disks that are internal to the scale-out file server nodes. So you see in the image here, we've got a Hyper-V cluster or Hyper-V nodes that are connecting to a scale-out file server using SMB3 networking. A scale-out file server is built up in this case of 4 nodes, and each of those nodes, instead of being connected to shared JBODs, they're using internal disks. Now there's a few advantages to this. We've flattened the architecture so it's easier to price and easier to scale. But we're now starting to use a different kind of disk. We're not locked into SAS. We're now able to use much cheaper SATA disks. This means we can start using SSD or even NVMe for great performance. And on the HDD tier, if we choose to even implement HDD on the second tier, we get a new level of scalability and performance by having mixed mirror and parity. So we have mirror for performance and parity for scale. And our data will transparently move through that, and the flash storage gives us great persistent cache performance. As you'll see in this next slide, Microsoft have gone one step further with Storage Spaces Direct. They said, that's great, we have the ability now to do Storage Spaces Direct on one tier, and Hyper-V on another tier, but the industry is jumping on something called HyperConverged Infrastructure. And this is where everything is flattened into a single tier. So in this case, the scale-out file server nodes are also Hyper-V nodes. Each node in the cluster is both storage and virtualization or compute. Now, the common question here is, okay, I thought Microsoft said loopback SMB shares weren't allowed. There is no shares here. There is simply a CSV or a collection of CSVs that span across all of the nodes via replication, SMB3 traffic. And this is where you want to start looking at RDMA and 10 gig and faster networking. Flatten the infrastructure completely. So this means that deployment is, okay, I need 4 nodes, I need 8 nodes, I need 12 nodes. And I simply add nodes as my cluster needs to grow. Now this trade-off here is your growth is pretty much aligned across compute and storage. So your compute and storage have to kind of grow at the same level. But it is a whole new infrastructure design that is going to suit a lot of customers out there. And it's going to give them a different way to doing hyper-converged infrastructure. Now, storage is one pillar of any cloud or virtualization deployment. The other pillar is networking. And we've already mentioned networking a number of times so far in this presentation. Microsoft have really done a lot in 2016, and most of this, if not all of it, is inspired by Azure. The first of these is something called Network Function Virtualization, or NFV. Now you think about if you want to put in a firewall or a load balancer in your network, well, there's 2 ways you've probably done it in the past. One is you've bought physical appliances from your traditional vendors, and you've put those onto the physical network, connected them up onto your switches, and your HyperV hosts and your virtual machines connect to those functions in some way, shape, or form. The second way is you can run virtual appliances. So you might run a virtual machine that is a firewall or a virtual machine that is a load balancer. And if you've used the Azure Marketplace, this is something that's not new to you. Now if you've used Azure, you've realized, well, Azure gives me a kind of a basic firewall mechanism called network security groups. That's kind of interesting because I don't have to deploy a device for that. It's just in the fabric. And we also get load balancing in the fabric. I just say I want these 3 or these 10 virtual machines load balanced. I don't have to worry about load balancers from third parties. I don't have to worry about Windows load balancing. I just have something that's in the fabric. And we're getting that in Windows Server 2016. The virtual switch that you've been using is also undergone some improvements. There's 2 things there that are significant. The first is switch-enabled teaming. And now this basically means that we don't have to deploy a NIC team and then deploy a virtual switch that's connected to the NIC team. The virtual switch contains the NIC team. And it has the usual configurations that you'll know from 2012 or 2, and it's got the recommended solution enabled by default. Basically, the way to think of it is the 2 physical NICs that you connect to your switch will basically be 2 uplinks on your switch. That's the way to think of it. It's a nice, simple solution, and really works out well. The other thing we've got to talk about is software-defined encapsulation. So a lot of you will have heard of software-defined networking. Microsoft invested and bet big on something called NVGRE, but the industry in general went with VXLAN. And Microsoft, well, the new Microsoft is very embracing of what the world is doing. So Microsoft in 2016 doing NVGRE and VXLAN. And this leads us on to something called the network controller, which is a new role in Windows Server 2016 and is literally ported from Azure. In the past, if you did software-defined networking in Windows Server and Hyper-V, you had to use System Center Virtual Machine Manager as that point of deployment and management. You deployed your logical networks and your virtual networks, and you had SCVMM being responsible for updating virtual network tables across all of your hosts. And that became a single point of failure that unfortunately failed too often. So a lot of people who wanted to do software-defined networking kind of really couldn't and had to stick with the traditional VLAN approach. This changes in 2016 because now we have a dedicated feature called a network controller. That network controller is going to control and manage the entire north-south and east-west network stack. So your virtual switches, your software-defined networking with NVGRE and VXLAN, your network virtualization functions, all managed from that network controller. Now realistically, for those of you working in the small medium enterprise market, you're not going to deploy this thing. Network controller is for the bigger enterprises and particularly the hosting companies. So this is very large deployments. And yes, you will still probably deploy this using Virtual Machine Manager, and you will manage it using something called the Azure Stack, which is coming up next. Microsoft Azure Stack is a whole new product, and this is a big thing from Microsoft. You're going to hear a lot about this in September at Ignite. In fact, you're hearing a lot about Azure Stack at the moment, and there's a big preview at the moment where you can download this and run it on one big beefy virtual machine, or one big beefy physical machine. What Microsoft have done is they've taken the user interface and the Azure Resource Manager fabric from behind that interface of the Azure portal and brought it onto something that you can run on-premise, either in a large enterprise or in a hosting environment. So they've taken that Azure portal, codename Ibiza, that a lot of people have had negative feedback about, but it has improved significantly. I was one of those negative people early on, and now I really do like using that new interface. They brought Azure Resource Manager, and they brought that down into the Azure Stack, and we have the same PowerShell commandlets. So we can use those same ARM commandlets against Azure and against Azure Stack. Consistency is a big word from Microsoft about this. It is an Azure consistent environment. Effectively, you are deploying Azure on-premise. And Hyper-V, which runs in Azure, will also be running on your own deployment of Azure. It's a massive investment by Microsoft. It's a significant development. I think it's a huge improvement over what Microsoft tried to do with the Windows Azure Pack or Webpack. It is a different product. It's not something that's going to upgrade to Azure Stack. For the time being, they're going to sit side by side. Webpack or Azure Pack very heavily relied on System Center. Azure Stack does not rely on System Center. It's very different. It's using a whole different approach, using the whole ARM architecture and the concept of resource providers to deploy and configure and manage the environment. However, it will still be best run with System Center side by side. So VMM would deploy your configurations, Operations Manager would monitor it. And that's a big thing for Microsoft.
All right. Thank you much, Aidan. Appreciate the insight and the information there. That's all good stuff. So from here, we got just a slide or two regarding Altaro VM Backup, and then we're going to get to our Q&A in just a second. So real quick about Altaro VM Backup, again, that is our flagship product, and it's, again, trusted by 30,000 SMBs and 4,600 IT resellers and MSPs. We really focus on three big things here at Altaro. Software has to be easy to use, and it has to be super easy to deploy. Because we understand that, you know, in the SMB and the SME space, you might have Bob from accounting running backup. So it's got to be fairly simple to use. We also focus on highly capable software that provides unbeatable value. We want it to be great software that does what you need it to, but we don't want to break the bank at the same time. And then the other thing that we really focus on is outstanding support. When you call Altaro support, you're not going to get the usual have you tried turning it off and turning it back on type of thing. You're not going to go through that escalation procedure. You're going to get to an engineer that owns your issue from A to B and is friendly, helpful, and will fix your issue. If you're an IT reseller, we do have an IT reseller program. You know, it's free to sign up, free partner training and certification, no commitment. If you want more information on that, go out to altaro.com/partners or email sales@altaro.com. And then again, like I said, our flagship product is Altaro VM Backup. We're very proud of it. You know, and we know a lot of people like it, and we hope you will too if you want to give it a try. If you want to try it out, again, the download link is altaro.com/download. You can get a 30-day full-feature trial, or it's free for 2 VMs forever. So a couple of different options there to try it out. So with that said, we've got a little time here for some Q&A. And if you have any questions, go ahead and use the questions form inside of the application. And I'll go through some questions here, and we'll see what we can get answered. So let me take a look here. First question I see here. Any future support for virtual fiber channel support for Linux? I don't do a whole lot in production with Linux or fiber channel myself. I don't know if you can speak to that at all, Aidan?
I'm in the same situation because most of my storage is SMB3 or iSCSI. I haven't heard anything there. Yeah, I can't say I've heard anything at all in that space.
Yeah, I mean they've been pushing development and
Yeah.
marketing for SMB3 so hard that I'm not sure that they've worked on Fiber Channel a whole lot. So okay.
What I will say is that they are very, very keen on increasing functionality for Linux virtual machines. They are dead serious about that.
Oh yeah, yeah, you definitely see that quite a bit. Absolutely. Let's see. Is the storage replica feature only supported when you use a soft infrastructure? Can you speak to that, Aidan? Do you know on that one?
The requirement for storage replica is that you're running the Datacenter edition of Windows Server, and well, that's currently how it's announced anyway. I don't think that's going to be changing. You do not need a scale-out file server. You can do this with local volumes. You can do this with CSVs on block storage, so SAN, and you can do this with scale-out file server. So if you want to do a very simple deployment where one host is replicating to another host, you can do this. The main thing is really going to be the network requirements. You are going to need fast networking for this. And I would say have a look at Microsoft.com and you'll be able to see the information on that evolve over the next few months.
All right, good stuff here. Let me take a look at our next question here. Oh, it just moved on me. I had it and then it's and then it scrolled on me. Let's see here. What are the AD schema requirements for rolling cluster upgrades? I know personally myself, not that I'm aware of. Of course, in all the situations that I've tested that, the whole environment's been technical preview of 2016. I'm not aware of any. It sounds like you're not either.
I don't believe there are any. No, I don't believe there are any at all. But then we'll probably find out in about 3-4 months if there is or not. But I don't believe there are any at all. So I compare it to an Active Directory upgrade, but it's really not an Active Directory upgrade. It's just logically it works like an Active Directory upgrade.
Yep, yep. Let's see. Lots of good questions coming here. I think we've got another 2-3 minutes here for questions. Let's see. Trying to find a good one here. Is it possible to POC Azure Stack using nested virtualization? So from my understanding, it requires one massive host. If I remember correctly, isn't the requirements like 96 gigs of memory or something, Hayden?
I think it might be 192 gigs of RAM.
So I knew it was big.
I know it's big. It's big. It's 5 individual disks that are capable of doing storage spaces. So you need RAID disabled on the storage controller. And it is actually going to do nested virtualization because you're basically running one physical machine that a Hyper-V cluster is going to run on. So it is actually going to be doing nested virtualization.
Good, good. Another question here about Azure Stack. Is there an upgrade path from Azure Pack to Azure Stack? And to my knowledge, the architectures are so fundamentally different that there is no upgrade path. Is that what you've heard, Aidan?
Yeah, that's what I've heard. It's basically like comparing Azure V1 to Azure V2 or service management to ARM. They're two very different beasts.
Yep.
Going forward, we're going to have this consistency with Azure, so once you are on Azure Stack, the good news is you're there. Now, Webpack is not dead. Development still continues on that because Microsoft do have significant customers running that solution. So that solution will continue to run side by side with Azure Stack, and customers will have a choice. Do I do Webpack with System Center, or do I do Azure Stack? I think a lot of people are going to say, you know what, it's my first time doing cloud with Microsoft. I'm going to go with the one that's consistent with Azure, and that's Azure Stack. But those who are running the legacy system will still continue to get that. And you see the same with storage spaces. So there's a lot of talk about storage spaces direct. but the JBOD and cluster in a box approach will continue to be used and developed in 2016.
Yep. So let's see. Is upgrade from Windows Server 2012 R2 to 2016 free? It's going to be a paid upgrade from everything I've heard. And
yeah, if you've got software assurance, it's free, or if you're in subscription licensing, it's free. But if you have OEM licensing or you bought volume licensing without software assurance, you will have to pay for a new license. However, if you want the functionality of a new version of Hyper-V and you don't want to upgrade the versions of your virtual machines, you can deploy Hyper-V Server 2016 because that continues to exist for that very reason.
Another question here, is there a core version? And I'm guessing that question is referring to server core. With 2016, we actually have 3 different modes now. We've got your standard server with a GUI. We've got core mode, and we also now have nano server as well, which that's really exciting stuff for me personally. I don't know if you've messed with nano a whole lot, Aidan, but that's some really cool stuff, especially for Hyper-V. Some really neat stuff going on there.
Yeah, my TP5 cluster, which is actually a nested cluster, is running nano server. So nano server is Windows without any user interface, and it is small. When you run it as a virtual machine, it requires less than 200 megs of RAM. It's crazy small. It has a tiny amount of disk space. In terms of patching, it's going to be a tiny amount of space. The gotcha is there's no user interface, so hardware troubleshooting will be interesting. The GUI for managing it actually resides in Azure. So it's going to be interesting. I think large customers are going to love it. I think small customers are going to steer clear from it like it's got the plague.
Yeah, exactly. I mean, those smaller customers, a lot of time they don't have dedicated IT help, and if they do, it's usually someone's grandson or someone's friend or something. So I can definitely see that. I know one thing about nano server that I thought was really cool was the prospect of not as many security patches. If I remember correctly, the metric that I've been seeing is 80% less critical vulnerabilities. So that's definitely a lot of benefit to that.
Or the other cool thing, blink and you missed the reboot.
Yeah, exactly. I know when nano server first started, it was a little difficult to deploy, but now they've got a collection of PowerShell commandlets that make it a lot simpler to deploy. And now they also have what's called the nano server recovery console, that you can actually look at the console of the machine and actually make changes to the NIC settings and the firewall settings. So that was a big help for a lot of people as well.
And reset W or WinORM, which is a big one as well. Affects a lot of VMM customers.
Yep, good stuff. So at this point, I think we're just about out of time. Any questions that were not answered during the Q&A here, again, we're going to be keeping track of them, and we will do a follow-up blog post out at altaro.com/hyper-v. There'll be a follow-up post containing all the questions we didn't get to with their associated answers, and we'll also have a recording of the webinar as well. So if you missed something or you had to step out for a few minutes, you can come back and view the recording as well. So at this point, I'd like to say thanks everyone for attending today, and I'd like to say thanks to you as well, Aidan. Thanks for taking the time to come here and talk to us. And
thanks for having me in.
Hey, not a problem. Always a pleasure. And then outside of that, have a great day, everyone, and enjoy. Thank you much.